Welcome to section 3.1, Solving Linear Equations. The first part, we'll be going through solving linear equations with a variable on one side of the equation, or of the equal sign. So the first thing we want to do is isolate the variable. What I like to think about is doing the order of operations backwards and opposite. So instead of PEMDAS, or please excuse my dear Aunt Sally, you think of Sally and my, or dear my, excuse please. Anyway, so we take what's happening and we go in the reverse and do the opposite to undo what's happening. So right here, what I see happening to the y is it's being multiplied and has a subtraction. And because I'm going backwards, I want to work with the subtraction part first. Please excuse my dear Aunt Sally, the subtraction's at the very end, which means I'm starting with that in undoing and unraveling this order of operations. So I'm going to come down into here, and so I have 0.3y, I haven't done anything to that yet, and then I'm going to do the opposite. So I need to add 3. So I have a subtract 3. I'm going to add 3 to this side. But to keep things balanced, I also need to add 3 to this side. And in doing the opposite, these will cancel out. So we're going to get to the point where I'm not going to show you doing it on both sides. I'm just going to do the opposite to the other side because it will always cancel out with what I'm doing on this side, which is good. That's what we want. So down here, I'm left with 0.3y equals 267 plus 3 gives me 270. And I'm going to need a little more room, so we'll come over here. So we'll just move our work up to this direction. Now remember, I'm doing the order of operations backwards because I want to undo what's happening. So I'm going to copy this. Oops, that made a big mess. Nope, still didn't work. So we'll just come over here. That didn't work either. Okay, so we have 0.3y equals 270. So now the opposite of what's going on. In between the 3 and the y, I have a multiplication sign, so I need to divide that. So I'm going to divide by 0.3, and I'm not in an equation editor right now, so I'm just going to underline that just to demonstrate that I'm going to be dividing by 0.3. And I need to divide that on both sides because it needs to stay balanced. So I'm going to divide this side by 0.3. Now 0.3 divided by 0.3 is 1. So I'm going to, there we go, strike it out. And then I'm left with y on this side, which is what we wanted. We wanted to isolate the variable. So now I have y equals 270 divided by 0.3. So I'm going to type in 270 divided by 0.3 in my calculator. And the answer is 900. So we're going to come over here, and I'm left with y equals 900. And I don't want all of that to be underlined. We should do the equation editor next time. There we go. There's my answer. Okay, so now let's move to the next example. Now this one, I have several variables. I have this negative 6p, p, and negative 12p. So the first thing I need to do is make them into 1. So combine them all. So I have negative 6 plus 1 is negative 5. Minus 12, so I have negative 5 and a minus 12. That will give me, I'm going to keep working inside the editor. Oh, it's not letting me. So we'll just insert. Okay, so I have negative 5 and negative 12. Gave you a lot of time to think about that, which gives me negative 17. And I still have the p attached. And I didn't do anything to the 8 yet. Equals 26. Okay, so now the next thing I need to do is get the p all by itself, and I look at all of the operations happening here. I have a multiplication sign here with the 17 and a subtraction with the 8. And again, I'm going opposite and backwards of the order of operations. So I want to get rid of this negative 8 first by adding it. So the opposite. So I'm going to, on my next line, insert an equation. Oh, my computer, there we go. So now I have negative 17p, and I'm going to be adding the 8, so I have 26 plus 8, and 26 plus 8, oops, I should be doing this by hand. This is getting kind of crazy out here. Okay, so now I'm going to move up here since I ran out of room. I have negative 17p equals 26 plus 8 gives me 34. So now I need to get rid of this 17, and instead of trying to work with the equation editor right now, I'm just going to do this by hand. So now I'm going to divide this by my negative 17. Negative 17 divided by negative 17 cancels out, which is good. That's what we wanted it to do. Remember, we're doing the opposite. And I need to divide this one by a negative 17 as well. And that leaves me with a p on this side, and 34 divided by negative 17. So that gives me p equals 34 divided by negative 17. A positive divided by a negative is a negative. 34 divided by 17 is 2. So there we go. P equals negative 2. All right, let's move to the next one. Negative 4r minus 9 equals 17. So this one's very much like the first example, simplified from what the second example was. So I need to do the order of operations backwards. So I'm going to add the 9 to both sides, and I'm left with negative 4r. I'm not going to show adding the 9 on the left side because I think we're okay with going ahead and just adding it now to the other side, because when I add it, it cancels out on the left. So I get 17 plus 9. Oops. There we go. So my next step will be dividing by that negative 4. So I have negative 4r equals 17 plus 9 gives me 26. And that now I need to do just what I did in number 2, divide both sides by this negative 4. I'm going to scoot over, and I have negative 4r equals 26. Divide those both by the negative 4, and it cancels out on the left. Divide by negative 4, and it cancels out on the right, or it reduces on the right, and I'm left with, on the left hand side, because it's canceled out, I have r. 26 divided by negative 4 does not go in evenly, so I'm going to type in 26 divided by negative 4 equals negative 6.5, and we're done, which matches my answer on the other side, and I'm going to highlight it to show that's the answer. All right, let's move to the next one, number 4. If you watched the previous tutorial, we kind of talked about having a division sign, a long division sign. Even though it doesn't have the traditional parentheses at the top, we can assume that those parentheses are there every time we see a long division sign. So even though I don't have them in here, when I talk about the order of operations, please excuse my dear Aunt Sally, or PEMDAS, then I need to remember that that over there is one little unit. So I'm not going to be doing the subtracting 3 and doing the opposite, which would be adding to both sides, until I take care of this multiplication division sign right here with the fraction line. So what I need to do on this one, and I'm going to just have to do this by hand since we're having issues with the formatting. So the first thing I want to do is get rid of this 9 on the bottom, because there's nothing else here adding and subtracting outside of this fraction. And please excuse my dear Aunt Sally, I would be adding and subtracting first because those are the last things, and I want to do the opposite. So I'm going to, didn't have adding and subtracting, so next is my dear, or dear my, because we're going backwards. And so I need to get rid of this 9. And the opposite would be multiplying, because here I have a division sign. So I'm going to multiply by 9. And the reason I can do that is, or that I should do that, is that it cancels. 9 divided by 9 gives me 1. And I need to do that over here as well, and that'll actually be nicer just typing it out, times 9. So now I have on the bottom 5x minus 3. Nothing else is on that side because I got rid of the 9. And then I have 18 times 9 on the right hand side, or 162. Now my equation looks very similar to the first 2 examples, so I need to get rid of the 3 first by adding 3. So my next step will be 5x. I'm going to be adding 3, so I know that it is canceled out on the left hand side. Add my 3 to this side. I'm going to show that I add 3, which gives me 165. Oops. Now, the last step I have is just getting rid of this 5 times, so I do the opposite, which is divide by 5, and we're going to come up here to show that. 5x equals 165. Divide by 5, a very large 5. Divide by 5. Now you know why I type all of my notes. 5 divided by 5 cancels. So I'm left with only x. And then I have 165 divided by 5 gives me 33. All right, and that's our answer. Let's move to the next example. So this one we're getting a little harder and a little harder, and this one I kind of have a combination of things. So now I have parentheses, I have multiplying outside of those parentheses, and this addition. Remember, I'm doing the order of operations backwards, and to get rid of them, I'm doing the opposite of what's happening. So the first thing I know is that adding and subtracting is at the end of PEMDAS. So here I need to get rid of the 12. So I'm going to add it to the other side. And because I already have this typed up, I'm just going to copy and paste it in to speed us up. So I'm going to subtract it from both sides, which means it cancels out on the left side. And then I subtract it from the right. And then I'm left with negative 10 times parentheses, negative 2m minus 4 over 90, and then over here I subtract 12, which gives me 38. Okay, so now using PEMDAS still and going backwards, the parentheses is the very first thing in PEMDAS, which means it's the last thing I take care of when I'm working it through backwards. So the next thing I want to do is divide by negative 10, because 10 is being multiplied. So if I divide this, and I'm going to come up and add in my fraction, divide this by negative 10, these will cancel out, but I have to do the same thing to this side and divide this by negative 10. So this, let's go ahead and show that that's going to cancel out. And then what am I left with? I'm hoping this will speed us up and hopefully keep everything nice and orderly as well. 38 divided by negative 10. I know that dividing by multiples of 10 moves the decimal over, and that's all it really does. And a positive divided by a negative is negative. So this is just negative 3.8. Okay, now I can kind of drop off those parentheses because it's the only thing left and get rid of what's inside. And again, I need to do the opposite of the order of operations. Because this whole thing is on the top, I'm going to assume that those are kind of stuck together. And the next thing I need to do is multiply by 90. And so we're going to come up here and times by 90. In doing so, it cancels out because 90 divided by 90 is 1, and that's exactly what we wanted to do to isolate the variable. And then on this side, I'm going to times by 90, and I'm left with, you know what, let's just get rid of all of that. Negative 2m minus 4, and then I have a negative times a positive is negative. 3.8 times 90 gives me 342. Okay, now we've simplified it to look what the previous examples looked like. So now I need to get rid of my negative 4 because I'm still moving backwards. And now that I've gotten rid of everything else, I just have the adding and subtracting and the multiplying and dividing right here and here. So I'm going to add the 4. And we're going to come up here to do that. So I have negative 2m equals negative 342 plus 4. And over here, I have a positive 342, so I'm going to type in negative 342 plus 4 gives me negative 338. So I have my next step being negative 2m equals negative 338. Now I need to divide both sides by negative 2. So I'm going to divide this by negative 2. And I could show you again to divide by negative 2, but we're having problems with the formatting on my computer, so we're just going to divide it by negative 2. And so the next step would be m because the negative 2 cancels out. And then the negative 338 divided by the negative 2, negative divided by negative is positive, and type that into my calculator and got 169. There we go. Okay, let's move on to 6. Okay, so here's my variable, and I want to isolate it. I have a multiplication sign here and a subtraction sign here, doing the opposite of the order of operations and backwards of that. Oops. Okay, so I want to add the 20 to both sides first. So I'm going to copy this and just paste it below. That'll help speed us up. Okay, so I have negative 5/3 f, and I'm going to be adding 20, the opposite. So I have negative 5/3 f. We're just going to throw that up here too. And I have 16 plus 20, which gives me 36 on this side. Now, how do I get rid of this negative 5/3 times f? Well, that does say times, and the opposite of that would be divide to isolate the variable with everything we've done so far. But we don't ever divide fractions. We always multiply by the reciprocal. So over on this side, I need to multiply this by the reciprocal, and the reciprocal of 5/3 is 3/5. So I'm going to hurry and insert an equation here, just a little fraction of 3 over 5, and this is all negative, so I need to make that negative as well. Why? Because a negative times a negative is positive, and that's what I want. I want this f to be all alone by itself. Isolating the variable is our goal. So f equals, and just to show that this really does cancel out, 3 divided by 3 is 1. 5 divided by 5 is also 1. 1 times 1 is 1. And a negative times a negative is positive, so the only thing left over here is 1 times f, or just f. But I can't just do it on one side. So I also need to make sure that I get this being multiplied by the reciprocal, which was negative 3/5. Now, I'm going to just come over here and do 36 times negative 3 divided by 5, and there we go, negative 21.6. And that's the answer. Okay, let's try the next one. Again, this one's one of the more difficult ones. Oops, there we go. Okay, so the first thing we want to do is the opposite. So I have this addition sign. We know that by now, the order of operations, we go backwards. So I want to subtract this 16 to get rid of it. So I'm going to highlight this since I have it all typed in. And my next step will be subtracting the 16. Subtracting it from the left side cancels it out. Subtracting it on the right side gives me 6 minus 16 is negative 10. Okay, so now the next thing I have these set of parentheses, and I don't want to mess with that until the end, so I want to get rid of this 5. That 5 is being multiplied by those parentheses, so to get rid of it, I need to divide. So I'm going to divide this by 5, which means I also need to divide this one by 5. Over here on the right-hand side, that will cancel out, or the left-hand side. On the right-hand side, negative 10 divided by 5 gives me negative 2. So I'm going to get rid of that, and we know on the right side, whoops, I have negative 2. There we go. Okay, so now I can kind of theoretically get rid of these parentheses and work on the top and the bottom. So the top part though is still combined, so I need to just get rid of this bottom part. So I need to multiply that by 8, which is the opposite of it being divided by 8. Which means I also need to do that to this side, which is multiply it by 8. And I'm going to go ahead and highlight this just to speed us up a little bit. This formatting is just getting the best of me. Oh well. Okay, so now I have this is gone, and on the bottom here, that's gone, and I'm just left with what's inside, negative 3d minus 61, because the 8's canceled. Negative 2 times 8 gives me negative 16. And now I've simplified it down to what we're familiar with on the first three examples. So here I have a multiplication, and again, I can theoretically just drop off those parentheses because nothing else is going on the left-hand side. And so now I need to add 61 to both sides. I'm just going to highlight this again for my next step. And adding 61 to the left-hand side cancels it out. Over here, I'm going to add 61 here. So I have negative 16 plus 61 gives me 45. Oops. So over here I have positive 45. Now the last step is to isolate this d, and because I have that 3 being multiplied to the d, I need to do the opposite, which is divide by that negative 3, and do the same thing on the right hand side to keep the equation balanced. And over here, negative 3 divided by negative 3 cancels, and 45 divided by negative 3 gives me negative 15 equals negative 15. And there's my answer, which matches my number 7. All right, moving on to number 8. The last example of what we've been dealing with on numbers 5, 7, and 8. These ones are, I guess, the more complicated because there's a few more steps involved. Okay, so the first thing we want to do is isolate the variable, and the negative 3 out here is the end of my PEMDAS, so I want to add 3 to both sides. So I'm going to come down here. Oh, that's as good as it's going to get. Okay, so I want to add my 3. And that gives me 38, and since I'm running out of room, I'm just going to throw that down. And now I need to get rid of this 4. I can't work with the parentheses yet. There we go. And over here, do the same thing on this side. There we go. And over here, my 4's will cancel. And then over here, I have 38 divided by 4, which gives me 9.5. I'm just going to go ahead and put that down. Or, yeah, 9.5. Okay, so now I need to get rid of the 6 on the bottom because the top is still kind of grouped together. So I'm going to times this by 6. I kind of like this method better by just replacing things in here. Okay, so now the 6's will cancel on this side. I can go back and show that by striking it out. And then I'm just left with 8x minus 5 equals 9.5 times 6. So let's come over here. I'm just going to straighten this out just a little bit. So we have 8x minus 5 equals, and then we have 9.5 times 6, which gives me 57. Okay, now we're back to the nice and easy way of the first 3 examples. I need to get rid of this 5, so I'm going to add 5 to both sides, and that gives me 62. And then I need to get rid of the 8, doing the opposite. If it's 8 times, I need to divide by 8, again on this side. There we go. And divide by 8. There we go. X equals, so I'm going to come over a little bit for my next step. Normally I would be working down to make it nice, but I only have so much room on my paper, so this is just going to be kind of moving right. there we go. X equals 7.75. And highlight my answer. All right, the next part is working with solving an equation for a variable. I'm going to do that in part 2 of this lecture. Also, this part is more of the word problems. Again, I'm going to do that in part 2. So we're going to move to the part where we have variables on both sides, and it looks similar to what we were just working with. However, there is a difference here in that these equations have variables on both sides of the equation. So in our first example, I have an x on the left and an x on the right. And what I want to do is combine them. So the first thing I need to decide is which side do I want the x's on, the left side or the right side? And really, it doesn't matter. In this case, I'm just going to go ahead and move my x to the right because it'll keep my x's positive. However, if you want to move them to the left, I'd say the majority of people just move it to the left because then it looks like your answer with the x equals the number. It really doesn't matter though. So what I'm going to do is combine my x's by taking this x over to this side. In doing so, I have to subtract because this is a positive 7x. So I'm going to copy this, paste it here. Oops, this isn't number 21, so we'll get rid of that. Okay, so now I need to subtract that 7x, and normally I would put this below hand, but since I'm doing this on the computer, it's all kind of ending up more linear. Okay, so now that I have minus 7x, this is not working out as well as I had planned. Okay, so now that I've subtracted 7x on the right hand side, I'm left with 18 equals 17 minus 7 is 10x, and then I still have this subtract 2. Now that I have all the x's combined, I need to combine everything else that isn't an x on the opposite side. So here I have a subtract 2, which means I need to move it over to the left-hand side, and to do so I have to do the opposite. So I need to add 2. So on this side, if I add 2, I'm left with, or I am given, 20 to add the 2 to the 18. And I still have my 10x. So now I need to continue to isolate my x. To do so, I have x being multiplied to 10. So the opposite of that is dividing by 10. I can come over here, and I have to do that to both sides. So I'm going to divide the left side by 10 and the right side by 10. Over here, 10 divided by 10 gives me 1, so this cancels out. And I'm left with 20 divided by 10 on the left-hand side, which gives me 2. And it looks like I got a negative wrong when I typed in my answer. All right, I'm just going to double check that and make sure that we did it right. I subtracted that. Yep, it looks good. So x equals positive 2, and if you want to rewrite that as x equals 2, that works as well. So it would be x equals 2, and it looks that way, but it's the same difference. Okay, let's move on to 21. I have a t on the left and a t on the right. So I pick, since the last one I put the x's on the right to keep things positive, it would go ahead and keep things positive, moving everything to the right on this one as well, but I'd like to show a different way. So I'm going to move all of the variables to the left-hand side. So to do that, I need to move my 8t over to the left. Because it's a positive 8t, I need to subtract 8t from both sides. So we're going to copy this, paste, work out some of this formatting. Okay, so I want to subtract 8t. And if I subtract 8t over here, it cancels out. So I'm going to delete it, and then on the left-hand side, negative or subtract 5t minus 8t gives me a combined total of minus 13t. Now that I have all of the t's combined, I need to get all of the things without t to the right hand side. So I need to subtract my 91 over here. So my next step is subtracting the 91. 91 minus 91 is 0, so I'm left with negative 13t equals, the 13 is positive, and I need to subtract 91. 13 minus 91 gives me negative 78. So my next step will be negative 13t equals negative 78. There we go. Now I need to divide by negative 13 because it's multiplying here and I have to do the opposite to get rid of it. So I'm going to divide this term by negative 13 and divide this side by negative 13. On the left, negative 13 divided by negative 13 is 1. 1 times t is t, so I'm only left with t. Oops. And on the right hand side, negative divided by a negative is positive, so I know my answer is going to be positive, which is 6. So my answer is t equals positive 6. And I'm going to highlight it as my answer. There we go. And there's my answer there. Some of you may be thinking, why am I going ahead and doing this by typing and formatting and different things? The reason I'm going to go ahead and stick with doing this, not only is it easier for you to see versus my handwriting, especially trying to write as uneasily as it is on a computer, but also you'll have to do this when you move into Math 108. You turn in some of your work by showing your work on the screen or on your document that you turn in. So I think this is kind of giving you a heads up and kind of a step above the other students in Math 108 because you'll know how to do it on the computer. So I'm going to go ahead and keep trudging along even though it is more difficult than doing it by hand. Let's move on to number 22. Here I have my variable embedded, both sides on the left and the right. It's embedded in these parentheses, so I can't really isolate it yet, and I'm going to have to deal with the parentheses first. To do so, I can't add anything inside the parentheses on either side, so I can't combine those, so I'm going to have to go ahead and do the distributive property. In doing that, timesing the 0.3 into here and the 0.3 into here, that drops off the parentheses. So then I can go ahead and start combining things like I did in the two examples 20 and 21. So I'm going to do 0.3 times 100d. 100 is a multiple of 10, which just moves the decimal over 2 times. So that makes it 30d. Then 0.3 times 4 is 12. Move the decimal point over, it's 1.2. Okay, then over here I have negative 0.2 times 7, so it's still going to be negative because a negative times a positive is negative. 2 times 7 is 14, but I have one decimal place, so it's 1.4. And then I have a negative times, in this one I have a negative, so this gives me a positive. And then I have 13.5 times 0.2, which is 2.7d. Now it looks like the first two examples, where all I need to do is start combining my terms with d, and I pick a side and then I combine the terms without a d on the opposite side so that I can isolate. In this case, I'm going to just go ahead and pick the left-hand side, so I'm going to subtract 2.7d from both sides. In doing that, it subtracts it from the side it's canceled, and then I'm left with minus 2.7d on this side. to show my next step, we'll come up here to stay on number 22, and 30 minus 2.7 gives me 37.3D. I'm just going to verify, or 27, whoops. I'm just going to verify that really quick just to make sure I didn't make a mistake like like sometimes that happens on the board when I'm talking and writing at the same time. Okay, so 27.3, good, check. But I still have this plus 1.2, and on the right hand side I still have the negative 1.4. So now that I've combined all of my terms with the variable on the left hand side, I need to combine all the terms without the variable to the right hand side. So I need to get rid of this 1.2. The opposite of adding 1.2 will be subtracting 1.2. And if I subtract it on the left hand side, it cancels, so that's why I deleted it. And then I have negative 1.4 minus 1.2. Okay, so now I'm left with 27.3D equals negative 1.4 minus 1.2. So that's going to be a negative 2.6. All right, so now my variable is almost isolated. I have this 27.3 times D. So the opposite would be divide by 27.3. On both sides, 27.3. And I'm going to come over here, negative 2.6 divided by 27.3, which gives us negative 0.095 and so forth. So let's just go ahead and we'll round out 2 decimal places. Why? Because I said so. So we're just going to do that. And it looks like I got this wrong up here, so we're going to just change that to 0.0. Because we're rounding out 2 decimal places, the 5 is going to round the 9 up to a 10, so let's just put 0.10. All right, and since I don't have a whole lot of room down here, we're just going to put equals negative 0.10. Now, some of you might be thinking, well, how many decimal places are we supposed to round out? Fortunately for you, in your tests and so forth, everything's going to be multiple choice. If you're concerned about it, though, the more decimal places, the better. In Math 108, each of the assignments tells you exactly how many decimal places to round out. So in this class, just go ahead and pick the one that in your answers best matches the rounding for your answer. All right, number 23. So I have, again, variables on the left and on the right. So I need to combine 3 of them this time. Over here on the left, 7g minus 6g is only 1g. So I'm going to combine this, or copy, come down here and paste it. And 7g minus 6g gives me 1g. So that's just working on one side so far. But I still want to combine this term with the g, which is minus 4g. So I want to get rid of that by doing the opposite, which is adding 4g. If I were to do negative 4g plus 4g, it cancels out on the right. But I have to do it on the left as well to keep my equation balanced. And I'll be left with 1g plus 4g, which gives me 5g. Okay, so I'm going to come over here to give myself some more space, and so on this side I have 5g minus 19 equals 6. Okay, so now that I've combined all of my variables, I need to combine all of the terms without a variable on the right-hand side. So I need to get rid of this minus 19. The opposite of minus is add. So if I were to add 19 to that side, it would cancel. So I need to add 19 to this side. So now I have 5g equals 6 plus 19 gives me 25. And then to get rid of the 5 over here, I have 5 times g, so I need to divide by 5. Dividing by 5 on the left-hand side, 5 divided by 5 is 1. 1 times g is g, so I'm left with g equals 25 divided by 5 is 5. And I'm going to highlight this as my answer, and it matches that. Good. Okay, let's move on to number 24. Very similar to the previous example, number 23, I have 8j minus 3j. So I'm going to combine those on this side. And then I have this j on the right-hand side as well. Okay, so I have 8 minus 3j. Combining those gives me 5. And then I have this subtract j over here. I need to do the opposite to get it on the left-hand side of the equation. So I need to add j. To add j on the right-hand side, we'll cancel it out. So I need to add j to the left-hand side. So if I add j over there, I get 6j plus 0.5 equals 6.5. Now I just need to get rid of this next one, doing the order of operations backwards, remember? So now I'm going to do the adding and subtracting. So opposite of adding 0.5 will be subtracting 0.5. Subtracting 0.5 on the left-hand side cancels it out. Subtracting it on the right gives me 6.5 minus 0.5 makes this 6j equals 6. Now I have 6 times j, the opposite is divide, so I'm going to divide by 6 on both sides. On the left-hand side it will cancel and I'm left with just j, and 6 divided by 6 is 1, which matches my answer on the right-hand side, so that's good, and I'm going to highlight this, and there's my answer. Okay, 25. So again, I have a bunch of k's on both sides, and now I just need to combine them. I'm going to go ahead and pick the left side. So I have 6k, so that's on the right side, and I'm going to keep it over there, or the left side. So I'm just going to keep it, and I need to combine everything on the right side. So I have 2k and 4k. That gives me 6k minus 3. Now some of you have already picked up on what's happening here. Can you have 6 times a number and add 9 and have it equal to 6 times that same number and subtract 3? Can you have any number? Some of you are thinking, well, maybe 0. 0 times 6 is 0, so 0 plus 9 is 9. 0 times 6 is 0 on this side, minus 3 is negative 3. So that makes 9 equal negative 3. Does that work? But if you're not convinced, we can go a step further. Let's go ahead and subtract 6k from both sides. 6k minus 6k. We still have the adding 9. And then I have 6k minus 6k because I'm trying to combine all of my variables on one side, and that cancels, and that cancels, and you get 9 equals negative 3. Does 9 equal negative 3? Absolutely not. So I'm going to come up here and I'm going to say it doesn't equal. No, positive 9 will never equal negative 3. And this also, some of you can see it right here and be just fine, and say, again, this also doesn't equal. You can't take a number, times it by 6 and add it to 9 and have it equal to the same number times by 6 and minus 3. Some of you would like to go another step and say 9 will never equal negative 3. It's up to you however you would like to do this. Some of you might even want to go a step further and try and add 3 to this side so that you're still trying to combine stuff, and you're still going to end up with something kind of crazy, like if I were to add 3 over there, I'd get 12 equals 0. 12 will never equal 0. I'm going to come up and show it doesn't equal 0. It can never equal 0. So the answer here, if I come up with a crazy equation, the answer is automatically, there's no solution. There's no number that will make this statement true. So the answer is no solution. And you can stop at any point you want. Some of you will stop here and know that that's the answer. Some of you will like to go a few steps further. Personally, I do either. So let's go on to number 26. Here I have 9b plus 6b minus 5b. Oh, I have a bunch. So here I have 9 plus 6 is 15 minus 5 is 10. So this left-hand side I have 10b. Okay, on the right-hand side, 27 plus 3b. 27 plus 3 is 30. Subtract 20. 30 minus 20 is 10b. 10b equals 10b. Some of you have already stopped and you know the answer. Some of you would like to keep going, and that's totally up to you. Your own personal preference works. 10b equals 10b. Some of you are going to say, yeah, 10b will always equal 10b. Some of you would like to divide both sides by 10, just to make it look a little nicer. If I divide both sides by 10, I get b equals b. Will b equal b? Yes, forever and always. It doesn't matter what I put in here. Any number will equal itself. So the answer is all real numbers. Anything you want to put in there will work. Okay, let's move to the next one, 27. And I seem to have lost my, there's my answer. Okay, so 27, here we have some on the left and the right again. And again, this one, the variable is stuck inside the parentheses. So I'm going to have to do the distributive property. So I need 0.5 or half of 18, which makes 9v. And don't forget to multiply it into the second term. 0.5 times 15 or half of 15 gives me 7.5. Half of 15, yep, 7.5. Okay, so that's gotten our parentheses to kind of fall off. So now I have 6v plus 3v over here gives me 9v minus 19. Some of you have already stopped and you know the answer. I have 9v minus 7.5 equals 9v minus 19. That can't happen. I can't have a number multiplied by 9 and subtract different amounts and still end up with an equal sign. But some of you would like to go a step further, and that's fine. It's totally up to you, as long as you understand that when you end up with a crazy equal sign that it doesn't equal, then it's just like number 25 and we get no solution. Again, 27 is no solution, but if you'd like to keep moving on by combining things, so I can combine all of the v's on the left side, so I get 9v minus 9v. That cancels out all of the variables, so I'm left with negative 7.5 equals negative 19. That will never equal each other. Negative 7.5 will never equal negative 19. So it's another crazy equation, and our answer is no solution. All right, I hope you join me for part 2, in which we go through some of these story problems that are a little bit more in depth than our equations, just the simple solving equations.